Guys, I'm sorry again, my iPad just shut off my video. So let's do one with centripetal force. It says a skater moves with 15 meters per second in a circle of radius 30 meters. The ice will exert a central force of 450 newtons. What is the mass of the skater? So I know, I'm trying to solve for mass. I know that centripetal force is equal to mass times v squared over r. I need mass. I have a central force that they gave me here. That was 450 newtons. I also have a velocity or speed, which was 15. And I have a radius that they gave me, which was 30. So all I need to do is just plug these in to solve for mass. When I do that, we should get the mass to equal 60 kilograms. And I know that this unit is kilograms because, remember, a newton is equivalent to a kilogram meter per second squared. So that's how I knew that the mass would be measured in kilograms, because a newton, kilogram meter per second squared. Okay, the last thing that we want to talk about are tangential and radial acceleration components. So let's say that the velocity vector doesn't just change in direction, but now it also changes in magnitude. So maybe I no longer have this uniform circular motion, which can happen. So as a particle moves along a curved path, the direction of the total acceleration vector, A, can change from point to point. So at any instant, we can resolve acceleration into components. And what are these components called? These components are going to be called the tangential and radial acceleration. So for the tangential acceleration, that causes the change in the speed of the particle. Now, the tangential component is AT, so we're going to symbolize that as A subscript T. And AT is going to be perpendicular to the radius. So if we go back to our picture here, my tangential acceleration is perpendicular to the radius. Now, the radial acceleration, we are going to denote A with subscript r. And my radial component is going to be along the radius of the circle. So again, if I look here, my radial acceleration is along that radius. I can calculate the tangential acceleration by the following. The radial acceleration is going to be the same way. I can calculate radial acceleration the same way that I calculate centripetal acceleration, except it's going to be a negative centripetal acceleration. That negative sign indicates that the direction of the centripetal acceleration is toward the center of the circle, representing the radius of curvature. The direction is opposite that of the radial unit vector, because for us, unit vectors are always pointing from the origin at the center of the circle. So that's the reason why we have that as negative. Since these are my components for the total acceleration, if I want to define that total acceleration vector, then I would just do the same thing that we've seen in the past. The magnitude, which is going to be our square root of the tangential and the radial acceleration squared and then square rooted. And then the direction is going to be the exact same way that we found it in the past as well. So let's read this example and then we'll work on this together. So it says a car leaves a stop sign and exhibits a constant acceleration of 0.300 meters per second squared, and that's parallel to the roadway. The car passes over a rise in the roadway such that the top of the rise is shaped like an arc of a circle of radius 500 meters. At the moment the car is at the top of the rise, its velocity vector is horizontal and has a magnitude of 6 meters per second. What are the magnitude and the direction of the total acceleration vector for the car at this instant. So I'm going to take this off so I can put it on the, make a blank Promethean board. Okay, so if I'm thinking about what variables I was given, and first actually let's draw a picture. So I have a car that's going to be, that's a terrible arc, but it's an arc nonetheless. Here's my car. It's on the top of this arc. It's passing over a rise on a roadway. So I have my car passing over the rise on a roadway. I know that its horizontal velocity at that moment when it's at the top was 6. So V was equal to 6 meters per second. I also know it says that the acceleration, once it's parallel to the roadway, so when the car is parallel to the roadway, when it's here right now, then that acceleration, which would be my tangential acceleration, was 0.300 meters per second squared. I know that r, the radius, was equal to 500 meters. My goal is to find that overall total acceleration vector. So to do that, if I need to find the magnitude of that and the direction, I know that the magnitude for this is going to be equal to the square root of the square of the tangential acceleration plus the square of the radial acceleration. They gave us the tangential acceleration, but I don't have the radial one. I could find the radial acceleration because we know that it is a negative v squared over r. I was given a velocity there, and I would know the radius is 500 meters, so if I do the math, if I do the math there, my radial acceleration should come out to be a negative 0.0720 meters per second squared. So now I have the tangential acceleration, the radial acceleration, so I could plug that in for my equation, the total acceleration magnitude here, to find that the magnitude of that total acceleration is going to end up being 0.309 meters per second squared. But they also want me to find direction, so I need to find that angle. And I can do so by taking the inverse tangent of my radial acceleration over my tangential acceleration. If I do that, I'm going to get that angle to be a negative 13.5 degrees. So if I were to have broken up these into their acceleration components, my vectors there, I would have seen that the tangential AT was moving in that direction. I know that the radial acceleration was moving that way, so my overall velocity vector would be there, with my angle theta there. Alright guys, so this quick check question as well as this homework problem, that's what I would like you to have done for me on Monday, and I'd like it done at the beginning of class. We'll go over it together at the beginning of class on Monday, and we're going to continue with some more problems, just practicing with these, and then also start relative velocity stuff to finish up Chapter 4. So homework problem here, the quick check question, that's your homework. Have them ready beginning of class on Monday. If you have questions on either one of them, or if you just want to check your answer to make sure you're doing them right, send me an email and we can talk over the weekend to make sure that you're on the right page. So I will see you guys on Monday. I hope you have a fantastic weekend. Bye.